Okay, here's a couple examples I would have liked to have had time to do in class, but didn't. If we have f of x equal to the square root of x minus 2 and g of x equal to 3x minus 5, those are our two functions. What we're going to do is find negative g of x, f times g of x, f over g of x, and g over f of x. And then we're going to find the domain of each one of those two. Domain. So the first one we're going to do is negative g of x. So if we know g of x equals 3x minus 5, negative g of x is just going to be negative 3x minus 5. 3x minus 5. So it's pretty straightforward. And then you could simplify this to negative 3x plus 5. So negative 3x plus 5. The domain for that, what are the acceptable inputs? Well, this is linear. There's no way we're going to have a zero denominator because there is no denominator. And we're not going to have to take the square root of a negative because there is no radical in there. So this function is going to be, the domain is going to be negative infinity all the way up to infinity. So all real numbers. For f times g of x, we're just going to multiply this times this. So equals f of x is the square root of x minus 2. And then g of x is 3x minus 5. So we're going to multiply this by all of this in parentheses. 3x minus 5. We have to have the parentheses, otherwise we would just be multiplying f of x times 3x and then taking away 5. It would be different. So we need to put this in parentheses. What is the domain of this function? Well, again, there's no fraction, so we're not going to have a zero denominator anywhere. But we need to make sure that what's under the radical is positive or 0, but not negative. So we know x minus 2 has to be greater than or equal to 0. So I'm going to write x minus 2 is greater than or equal to 0. And now we can solve this just like an equation. So I'm going to add 2 to both sides, plus 2, and we get x is greater than or equal to 2. So that is our restriction. So I'm going to put this in interval notation. I'm going to do from 2 up to infinity because it's greater than or equal to 2. 2 is an accepted value, so I'm going to use the square brackets. That means it includes the number 2. And then infinity is not a number, so I'm going to use the parentheses. Okay, 2 down. F over g of x, or f divided by g of x, is just going to be a fraction with f of x here on the top and g of x on the bottom. So let me write that. We're going to have the square root of x minus 2 on the top, because that's what f of x is. And we're going to have 3x minus 5 on the bottom. 3x minus 5. And that's done. So now to find the domain, we need to make sure that A, we don't have any zero denominators, and B, we're not trying to take the square root of any negatives. So both of those are possibilities here. We're going to have two restrictions. First, let's look at this radical. We know that x minus 2 has to be greater than or equal to 0. So I'm going to say x minus 2 is greater than or equal to 0. And we already solved this one up here. X is greater than or equal to 2. Greater than or equal to 2. Down here, we need to make sure that 3x minus 5 is not equal to 0. So I'm going to put 3x minus 5 is not equal to 0. And then we can add both 5 to both sides, and we'll get 3x is not equal to 5 when I add 5 to both sides. 3x is not equal to 5. And now I can divide both sides by 3 to get x by itself. X is not equal to 5 over 3. So these are our two restrictions. So I'm going to write it in the set builder notation. So the domain is going to be the set containing x such that x is greater than or equal to 2. X is greater than or equal to 2. And, I'm not going to write out the word because I don't have space, x is not equal to 5/3. X is not equal to 5/3. And then I'll close our brackets here. So the domain is x such that x is greater than or equal to 2 and x is not equal to 5/3. Alright, that one is done. So now we're going to look at g over f of x, just if we switched these two. So then we'll have 3x minus 5 on the top now. and square root of x minus 2 on the bottom. X minus 2 on the bottom. And again, since we're just plugging in x and not a number, there's not a ton to do here. It's pretty straightforward. This is done. But now we need to find the domain. So when we look at the top, it doesn't matter what the top of a fraction is, right? So we don't have any restrictions on the top here. I mean, if x is a very large number, we'll just have a very large number up here. If x is a very big negative number, we'll have a very big negative on the top here. But either way, that's fine. Down here on the bottom, we have the square root of x minus 2. So we have to do two things. We have to make sure that the bottom doesn't equal 0, and we have to make sure that the bottom, what's under the radical, is positive. So I'm going to say x minus 2 has to be greater than 0, not greater than or equal to. Because if it is 0, we're in trouble. Because then we have division by 0. So x minus 2 is going to be greater than 0, not greater than or equal to 0. And then I can add 2 to both sides and I'll get x is greater than 2. And that is our only restriction. So then for the domain, I'm going to use the interval notation here. I'm going to say it goes, x is greater than 2, so it's going to be from 2 to infinity. And we're not including the number 2, so I'm going to use the curved bracket here. And we can never include infinity because it's not a number, so another curved bracket. So that's 4 quick examples, and I hope it helps.